Intermediate Algebra for Statistics, Finding Quadratic Models, Part 4. Lesson Objective: Determine whether to model a situation by using a linear model, quadratic model, or neither. Example 6. The annual sales of light beer and an imported beer are shown in the table on the next slide. Let f of t and g of t be the annual sales in millions of cases of light and imported beer that is in the year that is t years since 2000. A. Find an equation of f and an equation of g. B. Use the intersect on the graphing calculator to find the intersection points on the graphs of f and g. What do these points mean in this situation? So here we have our data. We want the years since 2000. So t is equal to 0, 1, 2, 3, and 4. Our light beer will be modeled by f of t. Imported beer will be g of t. First step, we have to enter the data in to list 1, 2, and 3. T will be list 1. F of t is list 2. G of t will be list 3. Now we want to put the stat plot on. We want to hit zoom and then number 9 for zoom stat. And here is the graph of the data for F. And if we change it to list 1 and list 3, this is the graph of G. Next, we want to hit stat, go to calculate, then number 4 for linear regression. This pastes linear regression command in the home screen. Next, we want to hit second and number 1 for list 1, and second and 2 for list 2. Hit enter, and we have our linear regression for F. R squared is 0.955. To find the quadratic regression, we go to stat, calculate, number 5 for quadratic regression. This pastes the command in the home screen. Next, hit second and number 1, comma, second and number 2 for list 1, comma, list 2. Hit enter, and we have our linear regression model. The calculator is giving us the values of A, B, and C, and we see that R squared is larger than the linear regression model. R squared is almost 0.97. To get a visual of both these regression models, I put the linear in list 1. Hitting graph, we see that the line is doing a pretty good job of modeling the data. Unselecting list 1 and typing the quadratic regression model in list 2, hitting graph, we see that the quadratic does a better job of modeling the data. So both visually from the scattergram and R squared, both are telling me that the quadratic is a better model. So we say f of t equals the quadratic model, which is 0.093 t squared plus 0.539 t plus 3.686. For g, we go to our linear regression command. This time from the home screen, we want list 1, comma, list 3, because G is in list 3. This is the linear regression model. R squared is 0.94. Next, to do the quadratic regression, from the home screen again, we want list 1, comma, list 3. And here we have our regression. Here we have our linear regression model. R squared is higher. It's 0.989. Let's look at the graphs. So list 1 is the linear model. It's doing an okay job of modeling the data. Next, if we unselect list 1 and in list 2 put the quadratic and graph, we see that the quadratic is doing a better job of modeling the data. So g of t will be the quadratic negative 0.15 t squared plus 1.39 t plus 11.14. So in this case, both f and g are quadratics. Next, to find the point of intersection, we type in f in list 1 and g in list 2. I had to play around with the window settings, but the window settings that I'm going to use for this example, x min is -5, x max is 15, y min is -1, y max is 15. Hit graph. We have a point of intersection here and a point of intersection here. Hitting second and trace, which is calculate, and selecting number 5 for intersect, we see that the first point of intersection is close to a -0.41, and the second point of intersection is when x is about 7.6. What do these points mean in the terms of this problem? Well, about a little more than 4 years before 1990, the number of cases of beer in the millions for light beer and imported beer are the same, and about 7.5 years after 1990, the cases of beer and the millions are about the same for light beer and imported beer. To find these points of intersection algebraically, we use substitution. We set the two quadratic equations equal to each other. So we have f equals g. This is an equation with only one variable, x. Moving all three values on the right hand side to the left hand side gives us a quadratic of 0.243 x squared minus 0.851 x minus 7.454 equal to 0. This tells us what our values of a, b, and c are. Plugging these into the quadratic formula, we end up with the expression 0.851 plus or minus 2.823, all divided by 0.484. Splitting this up, we get a value of a -4.1 and a value of 7.6. So according to the model, 4 years before 1990, the number of cases of beer for light and imported beer are equal, and about 7.5 years after 1990, the number of cases of beer were the same also. So next, if we take the year and plug it back into the model for t equals a -4.1, we want to find what is f of -4.1 or what is g of -4.1. These will be the same answer. Following the order of operation, square first, multiply, subtract, then add. And we see for the year -4.1, the number of cases of beer is approximately 3 million. So we would say, according to the model, in about the year 1986, the number of cases of this type of light beer and imported beer will be the same. The number of cases will be about 3 million. For the next time, 7.6, we substitute that back in to one of the models, do the arithmetic, and we have an output of about 13.2. So we would say, according to the model, in about the year 1998, the number of cases of this type of light beer and imported beer will be the same. The number of cases will be about 13 million. Thanks for watching.